Okay, very warm welcome and a very good evening to everyone. I'm Varun Sharma from Mindray, and this webinar is being hosted by Association of Practicing Pathologists Haryana chapter, President Dr. Santosh and Dr. Prashant being organizing secretary. So we thank both of them for organizing this webinar. This webinar will last till 10 p.m. As per our schedule, and there will be 4 sessions. The 4 sessions are like this. Dr. Rajan Verma would be speaking on chat to chat or not to chat. Dr. Pranab Day on use of AI in cytopathology, how it works. Dr. Sonal Jain on AI in hematology, present and future. And then Dr. Nalini Bansal on AI in histopathology, the road ahead. If you have got any questions pertaining to any session, kindly keep on writing in Q&A or the chat box. The committee would pick up the relevant questions and all of them would be answered at the end of the session. Now, I would invite Dr. Santosh Kumar, sir, to speak few words before we begin. Over to Dr. Santosh. Dr. Santosh, sir, do we have you?
Dr. Prashant, you can continue, please. I think he's somewhere.
Yes, Dr. Prashant, sir, maybe you should take over.
A warm welcome to everyone. Can you hear me?
Yes, sir, you're audible.
Yeah, a warm welcome to everyone, and I welcome all the delegates on this webinar. I am the Secretary of Association of Practicing Pathologists Haryana. We thought of organizing this webinar because the chat GPT is very new and it is upcoming, and we thought that we should have one channel where we can share our thoughts and our fears with each other. So we had created a WhatsApp group also where everybody can share their views and they can discuss. We are open, and we have a panel of speakers this time where they will be introducing us to the artificial intelligence. Actually, they are going to speak about the basics of artificial intelligence, and later on we are thinking of organizing another webinar where we can have a better view of artificial intelligence, and we can have some more complex issues which we will be facing. This chat is open, and please share your views. And now I invite the first speaker to please share his view. Thank you.
So, Dr. Rajan Verma, you can start sharing your screen. I'll cancel my share.
Thank you, Dr. Prashant, for the introduction. You can hear me very clearly?
Yes, sir, you're audible, visible.
Right.
Yes,
and
sir.
You can see my screen as well?
Yes, sir.
Yes, sir. Perfectly all right.
Thank you so much. So here I go. So thank you, Dr. Prashant, for introducing me. And I am Dr. Rajan Verma. I'm just like your fellow colleagues and pathologists with a keen hobby of technology, which I picked up about 20 years back when I thought of writing my own software for the lab. Dr. Prashant is very well aware of that. So I learned Visual Basic from the internet, and I started writing my own software. Works very well. So then it became a hobby to me. But today I was told to deliver a talk on Chat GPT. Now, Chat GPT, we need to understand, is just a drop in the ocean where we have many of these so-called AI chatbots. As we are talking, more and more are coming in and are mingling in our lives to help us and to lead us in a quick fashion. So before we go on to Chat GPT, or before we go on to the chatbot, we need to understand they're called the AI chatbot. They are the artificial intelligence chatbots. And so we need to understand what an artificial intelligence is, what is a chatbot before we jump on to Chat GPT. I'll be very clear in this presentation. This presentation is a very basic presentation about the AI and the chatbots. Do not expect a lot of working models to come in this presentation, which we have planned in the second part. The idea of learning AI is to first understand the basics, then go on to the more complex use of AI in so-called healthcare and pathology per se. So let me talk about the good, the bad, and the ugly of AI chatbots, as I call. So we need to decide whether we need to continue chatting with the chatbot or not with the chatbot at the end of this presentation. So to start with, what is an artificial intelligence we need to understand? It's a field of computer science which makes machines perform like humans. So this is a very important word, perform like humans. So we learn, we do problem solving, we do planning, we do reasoning, we do identify patterns. All this is done by artificial intelligence in the machine, except the difference is we have emotions, they don't have. Let's see what the future holds for us. But at the moment, it is learning, problem solving, planning, reasoning, and identifying patterns. So what I understand by artificial intelligence, it is a part of a data science. You know, data science is a much bigger field which has a part of artificial intelligence. In fact, machine learning again is a part of artificial intelligence, and deep learning is again a part of machine learning. So artificial intelligence encompasses machine learning and deep learning. These are new words for most of us, but we have been hearing them. Let's understand what they are. So what is a machine learning? As we know that any computer program to be run, it needs to be programmed in a particular fashion for the outputs. But machine learning is a type of artificial intelligence that provides computer with the ability to learn without being programmed specifically for an output. So what do we have? We have a labeled data. What do you mean by labeled data? Is a data which we tell the computer, this is A, this is B, this is C. And we write a machine learning algorithm so that it picks up from that labeled data and gives out an output which matches with the labeled data. A becomes A, B becomes B, and C becomes C. So that at the end of the day, it becomes a learned model. And this learned model, when it is fed in with an unlabeled data, a mix of jumble of this data is fed in without telling what is A, what is B, what is C. It is fed in this model. It gives a prediction of this is A, this is B, this is C, as per the previous learning by the machine learning algorithm. So the important part is there is an input, there is a machine learning algorithm, there is a model, and there is an output, which is the prediction. So what is this learning and how many ways we can make the machine learn? There are three basic ways to understand. One is a supervised learning, unsupervised learning, and there is a reinforcement learning. So let's understand what each of them are. In supervised learning, we have a known data. In this picture, we have a group of apples, and we tell the algorithm, these are apples, and the machine learns these are apples and gives an output. When you feed in a bunch of fruits, it picks out apples and tells this is an apple and this is not an apple. So this is a supervised learning where we already know the data. We tell the computer this is a known data, and the machine picks up the unknown data from the previous known data stored in its memory bank. And unsupervised data, there is no labeling of data. In this example, we have a bunch of fruits where you have mix of watermelon, mangoes, and apple. And we tell the computer to identify a particular pattern by an algorithm. The model separates out the different data or the outputs depending upon a pattern. It could be the color, it could be the size, it could be shape. So as we see, depending upon this pattern, there was no feedback. Remember, feedback from an individual telling this is a watermelon, this is a mango, this is apple. It is all done by the computer by itself as per the algorithm. So it separates the apple, mango, and watermelon. This is what is unsupervised data. So in a nutshell, supervised versus unsupervised. Now we know that supervised data depends upon labeled data. There is a direct feedback from an individual, and according to this, it predicts an output. While an unsupervised data, it is non-labeled. There is no feedback from the individual, but there is a structure to this data or a pattern to this data which the machine reads and gives an output. So these inputs, these situations which we feed in the computer are called inputs, and the solutions are called target or outputs. These are the words which are being used in talking in the AI language. Now we come down to reinforced learning. The reinforced learning, we have an object here. In this case, it is an apple. We tell the algorithm to read what this data is, and it gives a wrong message saying that it is a mango, where we given a reinforced feedback saying, no, you're wrong. Look at the shape and the size and the color. It's an apple. So the machine now learns, the algorithm learns by itself. And the next time you feed in an apple, it will automatically recognize it. Won't make a mistake. It will say it is an apple. This is called reinforced data. The computer learns by mistakes. This becomes more and more real as more and more inputs are given into the computer. Now, this was what is the machine learning. Now, there is a more complex way in which the chatbots respond, or most of the algorithms respond, is by deep learning. Now, deep learning is a part of a machine learning. It's a type of a machine learning. So what do we mean by deep learning? So deep learning is a subset of machine learning in artificial intelligence that has networks. Remember this word, networks, capable of learning. Now, this data, as we saw in the previous machine learning, is neither supervised, is nor structured. That means it doesn't have a pattern, or nor labeled, as we saw in the earlier 2 or 3 examples. But still, the machine learns. How does it do that? It does by a program neural network. I'll tell you what a neural network is. It's called deep neural learning or deep neural network, DNN, as we say. So just remember this word DNN. And how does the computer do this? Is we need to understand what a deep neural network in simple words. So you imagine an axon here of the brain, human brain. It has dendrites, it has a cell body, it has an axon and synapse to give out the output. In the same way, we have these input nodes, which are actually the dendrites. We have small nodes, which are the cell body, and we have the synapse, which gives out the output. So this doesn't have a structure. This is all done by programming through the computer language. The most common language that is used is Python. So as you see these lines, these are called the synapse, or these are called the weights. Now, these input dendrites or input nodes will run through algebraic equations which are fed into these weights. There are different equations for bringing out different outputs. So if a condition is true for one equation, it will give out an output, the others won't. What will happen is that particular output will go to the next node, and finally the next node again connects to another node by the synapse or the weight and another algebraic equation, and so on so forth till it comes out with a specific output which the user wants or the machine wants. Now you can imagine these nodes in DNN are billions of them. The nodes are billions of them, and the synapses are billions of them connecting them. One node can be connected to another node by multiple synapses, depending upon their algorithms and depending upon their algebraic equations. So the first layer, if you take this example, I have, I hope you understand in a very simple language that suppose we tell this DNN to recognize an animal. In the first layer, it will start recognizing the lines and basic shape of the animal. So this is the first layer of algebraic equation, which will tell you this is the shape of that particular object we are talking about. And in the next layer, it starts reading the complex features like eyes, nose, and ears. But as we go deeper and deeper, finally, the DNN will be able to tell this animal is this, and this animal is this, and this is different from the other animal. So this happens in milliseconds by running through billions of nodes and taking out a specific output. So this is just an example. This is a very, very small structure of the brain of AI, what we call. It's similar to our brain. You see an image here, it has got two outputs, oligodendrogram or astrocytoma. The MRI image, when it is fed into this model, it will run through multiple nodes. These yellow ones are the nodes. This is the input node, and this is the output node. These are the synapses. All of them are governed by algebraic equations. So finally, as per the machine reading, it will either give out a response of oligodendrogram or astrocytoma in this particular image. So this is how a DNN works. And nowadays, all the AIs are using DNN. The word ChatGPT uses billions of these deep neural networks. We can never imagine it is as complex, maybe not as complex as our brain, but it is evolving and making its own synapses and connections and learning so that it brings out more better results. Before we go on to any other discussion, it is very important. This will be covered in detail by the other panelists and speakers. But before we go on to the other part of this conversation, we should know what is digital pathology. As we know that any artificial intelligence requires a data to be fed in. Now, in cases of histopathology, this data will be an image from the slides. Now, this image cannot be a single click of a camera, a low resolution image. It has to be a very high resolution image to the pixel, so that every pixel is read by the algorithm, becomes a part of a node, and gives out an output. So this glass slide is made into a whole slide image, which is called a WSI. There are many types of scanners. I will not go into that. There's a different presentation regarding digital pathology scanners. So these scanners are called whole slide image scanners. You feed in a glass slide, it starts clicking photographs in milliseconds, and billions of photographs are clicked and stitched together to form an image, which is at the level of a pixel. And these will form the WSI image. Now, this particular image is either taken into a server or can be directly read by an observer to mark it or to diagnose. Now, from this server, it either goes to the internet or it goes to the machine learning software or the AI software. And when it is marked by a user, this AI will start learning from this image and will start giving an output, which will improve with more and more learning. So most of the users can see the same image at the same time. People can mark it at different places at the same time, make the AI learn. This is what is a digital pathology. It is an evolving science. We are seeing more and more of it. And the digital pathology, which I saw about 6 years back, has evolved a lot in our country. It has gone to places in other countries, but we have started adapting to it. But there are still reservations by the pathologists when they start reporting on digital pathology. We need to overcome them. Everything requires a training. So more training, and more training. So we need to train ourselves more in digital pathology so that we can in turn train the AI more to give us a helping hand when we are diagnosing a huge workload. So this is what is a digital pathology. Now, let's come to the topic. I have discussed the artificial intelligence. Now on this earth, we have a new species which were born, which were called chatbots. Now these chatbots were made by us humans. Why were these made? Why did we require them? Can we adapt to them? They very well adapt to us. There is no doubt about it. We need to adapt to them. And what are the advantages and disadvantages of running through chatbots? So in this introduction, I'll be covering the chatbot as a definition of chatbot, the purpose of a chatbot, the growing importance of chatbot, the advantages, the use cases in different fields, and of course the healthcare as well, and the future trend of a chatbot. So what is an AI chatbot? Now AI chatbot, remember, is not a physical structure. It is a computer program that is powered by artificial intelligence and natural language processing, which is NLP. Natural language processing means it enables human-like conversation with the user when it brings out a response to the queries or when it brings out the solution. So how this works? So AI chatbots uses a natural language programming algorithm to understand the user inputs, break down their language into structure, picks out the keywords, the intent and the context, and refers to its data and brings out a solution. So let's see an example here. There is a user who says, I want to find a Chinese restaurant. Now, this is a natural language processing. The AI picks up a word called Chinese, goes into its database, and as per algorithm, sees the intent and the context, comes back to the user and asks, what do you want to eat? Basically, it means, what do you want to eat in Chinese cuisine? So that if the individual says XYZ, it can bring out restaurants serving the best XYZ. It can filter out the data as per the user's intent. And this can keep on going till the user says, okay, I'm done with. So this is how a chatbot works. Very simple to see here, but very complex because this all requires a DNN which works inside a chatbot. So what are the different types of chatbots? They are rule-based chatbots. They are the machine learning-based chatbots. Very common nowadays are the machine learning chatbots. It all started with the rule-based chatbots. These follow predefined rules and scripted response limited to their capabilities. I've given an example here. There is a user who asks, what time do you open on Friday? Now there is a chatbot sitting in industry and it says, what time do you open up on Friday? Now the chatbot picks up a keyword, says time, and then picks up the intent, which means operation hours. And the intent, it makes a reply, we are open from 9 a.m. to 5 p.m. So this is a rule-based chatbot, very simple, can't deviate more from this because it's a very simple fed-in data. Now, as we know, most of us are using Amazon Echo, where you keep talking to the Echo and it keeps talking back to you and give you replies in NLP, natural language programming. So this is an example. There's an Amazon chatbot sitting at a banking site. Now these can be integrated into third-party websites as well. So when you open up a website of a bank, it says, "Welcome to the banking bot. Please log in to access your account." Now the user says, "Please log me in. My login pin is so and so." Now the chatbot at the back end is running through this data, through the deep neural networking, sees the intent and comes back in an NLP. It says good morning because it has been programmed to respond like that. And it directly tells the balance of the user, pulls out the data from the banking website, tells out what the balance is, and asks, "What can I do for you?" This happens in a very natural fashion. You don't realize that it is a machine which is working. You feel there is a human sitting there who's typing and sending the command back to you. So this is what is an NLP. This is a machine learning based chatbot using a DNN. Now, what are the different industries which are using chatbots? The top 11 industries that use chatbots. You must have come across all these industries in your day-to-day life. You have started seeing chatbots come up. You go to a customer care for repair of the AC. You go to banking sites. You go to e-commerce for selection of a product, for buying product. Healthcare industry, yes, I'll be talking about that, is also now started seeing these chatbots. Hospitality industry, human resources, food tech, ed tech, travel, logistics, automobile, real estate, and they're everywhere now. So you don't interact with a human, now you interact with a chatbot. So the applications of these chatbots in various industries are to give a customer support, as we have seen. It gives instant responses and assists with the common queries. In e-commerce, it assists the customers in finding products or making purchases. In healthcare, it facilitates collaboration between peer systems. That means when you have a history sheet with you from the ER room or the OPD room, this is fed into the chatbot, and it can actually analyze and decide which department you should be referred to, what are the medications you are taking, and it can also tell you that your prescription requires a refill because this is how often you're taking the medication. It might be out of medication. And it can also tell you about the disease you're suffering from and what are the hospitals can give rise to these facilities where you can go for this disease. And it can update your record in the EMR, picking up this prescription or picking up this history sheet. So this happens in the back end very fast. You don't realize it has already integrated your history sheet into its records for the future references. Now in finance, as we saw with the example, you can help with the account inquiries and transaction history. So everybody is now keen to know, there are so many of them. How do we choose? For what purpose we choose what? So I just made a list. This list is copied from a website called Zapier. Now Zapier is a very, very well-developed a company which deals into making of chatbots. You can make your own. Go to this website and you can program your own chatbot for your diagnostic setup. It is as simple as that. You don't require the knowledge of Python. You can try doing all this. So the leader Zapier mentioned is ChatGPT. Now this word has come in after so long. It's called ChatGPT. And the runner-up has come out to be Google Bard. And there are many open source which are called Hugging Chat. And you can build your own chatbot with Zapier. I personally prefer Perplexity over ChatGPT and any other because Perplexity gives you references to the solutions it has given. Just like a journal article, it is good for research. You can go back to that particular references and you can check the authenticity of the facts of the output which is given by Perplexity. So I'll come to ChatGPT, and we have different chatbots for different purpose, for content writing, for sales and marketing, for messaging. You know, we have something called the Amazon Code Whisperer. My son, who is a data scientist, uses GitHub Copilot for debugging his coding language. So these are there to stay. It has become a part of you. Earlier, to debug a particular syntax used to take. I used to sit overnight and see where the problem is and keep on doing permutation combination. But today, you pick up that line and you tell the chatbot to debug. It tells you this is how you debug. You copy paste and your program works. As simple as that. So let's come down to ChatGPT. Now, everybody is hyper about what this ChatGPT is. After our lives, what is going to become of us? Whether this ChatGPT is going to sit on desk and remove us. I will answer to that queries as I finish up the presentation. Now, chat is for chatting. GPT is known as generative pre-trained transformer. Now, generative, it generates a particular response by a pre-trained data. You know, I made you understand supervised learning initially, where you require a pre-training by an individual. Now, this pre-training has been done by billions of articles throughout the Wikipedia, the Google articles, the journal articles. Everything has been fed into this machine to learn and pick out facts according to the DNN. And the word transformer. Now, this transformer word is used for the DNN which the ChatGPT uses. It's a complex model where there is a reinforcement. It keeps on going into the DNN. There is a complete node system, which is called a transformer type of a model. So that is the name which is given, is you chat generative pre-trained transformer. Now, the developer is OpenAI. It has developed ChatGPT. The initial release was November 30th, 2022. And the stable release was May 24, just about 50 days back, a couple of months back, came out with a very stable release. The earlier release had some issues regarding output of data. See, the future in about a year's time, it has made itself so stable that I will give you some examples that how quick it responds and how true the database it uses and brings out the specific reply. It is written in language called Python because, as I told you, the synapse between nodes, the weights between nodes are to be written in a particular language to take the input and bring out the output. The engine, I will come to this, the engine which drives this ChatGPT is a GPT 3.5 or GPT 4. Now I'll come down to what is GPT 3.5, GPT 4, just touch upon it. I know it is becoming too much now. You are becoming less and less of pathology, more and more tech. But I will stick to basics. I will not go into complexities. So it's a huge science by itself. And the platform is basically, it is a cloud computing platform. It happens on a cloud. The type of program is a large language model. It's called LLM. Now, this LLM is a DNN, where there are billions and billions of nodes, so large that it's called a large language model. And I told you about transformer. It is a feedback mechanism, a DNN, which brings out the solution or the output. And of course, at the end of the day, It belongs to the species chatbot. So let's see what are the AI models of ChatGPT. What we usually use, most of us use, is GPT 3.5 because it's free for everyone. It is available free to everyone. Now they have come out with GPT-4 recently, which is only accessible to paid users. GPT-4 is a very enhanced version of this DNN, where it has learned by itself, brings out a very specific reply. I'll tell you the advantages of GPT-4 as we go further. So this app, the app actually takes the prompts you write. So the inputs which you give is the prompts. Now these prompts can be written in multiple fashions to get different outputs. I'll come to that when I demonstrate something. So the prompts you write, and this is passed on to this GPT 3.4, the engine. And this runs through the DNN and returns back to the app in a very conversational type of chatbot, the solution. So what we need to understand, what is the difference between ChatGPT and GPT? So if you imagine a Dell computer, or maybe a compact computer, or maybe an HP computer, this is a ChatGPT. And the brain behind is the Intel, and that is the GPT. So what is Dell to ChatGPT is GPT to Intel. So this GPT, the model, is not only used by ChatGPT, it is being used by many of the AI chatbots, and they are just coming out every minute as we are talking. Some are like Jasper, Write-Sonic. Now Bing's new AI-powered search feature has come in, which is called ChatGPT Plus. I'll tell you why they have come out with ChatGPT Plus. And now Google doesn't believe in GPT as a model. So it has come out with its own model, which is called Palm 2. Now they launch, as you happen to, you must have seen that launching show of Bard, which went flop. You know, they launched their Bard with a model called Lambda, which actually responded in a very bad fashion, and they had to get away with Lambda, and they moved on to Palm 2. Now Palm 2 is a model just like GPT, which is doing wonders now. So on the left, I have told you and I have summarized what is a GPT and what is a ChatGPT. GPT is a LLM, and ChatGPT is a chatbot which is powered by GPT. Let's not get very confused about all this. So we'll go on to the next slide. This is the interface of ChatGPT you get. So you get a search bar where you just write in an open language a freehand. So suppose I have written, hey, ChatGPT, I'm writing about you. Is there anything you'd like to say to the reader of this article? Now the ChatGPT, within seconds, you will see it, runs through its DNN, knows the intent, brings out the context, knows what the user wants, and it tells you what it is. It tells you it is an AI language model. I don't have personal feelings or emotions, thank God, but I'm programmed to be very helpful and informative. So you respond, it goes on like a chat. You know, you don't have to repeat it again and again. You say, thanks, keep up the great work, and it will pick up from there and say, thank you, and I'll help you more. Please don't hesitate for assistance. So this is how the ChatGPT works. This is a very simple interface which I gave you. I'll show you one or two examples of ChatGPT at the end so that you will know how it works. People who have not used ChatGPT will become very comfortable in using ChatGPT. Now, what is this ChatGPT 4? The GPT-4 which is common, it has given an expansion to the bandwidth has expanded to incorporate the ChatGPT programs or the GPT run algorithms to be incorporated with third-party apps. Very important. You must have used some apps like Expedia, Kayak, and Zapier, Wolfram. So But this is only for paid users. Let me tell you, the amount you'll have to shell out is about $20 per month. So how do you when you go to a Chat GPT plugin of Expedia? I'll give you an example. You go and type there. You say that I want a vacation with a family of 4 to Sri Lanka. It should include beaches and hills. I plan to travel on so and so date for so many days, and I'll be back on so and so date. Kindly make an itinerary. Within seconds, you will not imagine sitting at your home. You will get the cheapest air ticket on that date. You will get the best possible hotels. It will tell you to book it. The chat can actually book your hotel. It will give you the complete itinerary covering the hills and the beaches and your return flight back booked. And you don't need to keep hopping on the websites looking for flight tickets. This is what Chat GPT has done to us. It's amazing when you start using it. You will not go onto these websites and start manually typing now. Once you start using the plugins, but for that you will have to shell out some money. Now, very important. Let's compare quickly the difference or the similarities between Chat GPT and Bard, because these are the two most commonest ones being used nowadays. Bard is made by Google. It's called Google Bard. The difference here, and the most important difference and very big advantage of Bard is it can connect to the internet and pull out the data, and it can Google itself, So, but Chat GPT has a stale data to refer to. This data is as old as 2020, where they are trying to update it now. But if you want more recent data, it's Bard to be used. It brings out all the resources, which is a huge selling point here. The search results can also show you images, which the Chat GPT can't. It has a more DOS-like interface, the Chat GPT, but it gives you images here. You can edit your and keep on following with that reply. That's a very important thing. It lets you choose the solution you want. You can now export your prompts or the results directly to Google Docs or Gmail Draft. I saw a doctor doing that today. Exporting the list of WHO manuals to Excel. Many things can be done. I'll show you one more trick at the end of the presentation. There are many of them. You can keep learning and you can keep enjoying it. So at the end of the day, Bard is built for research, whereas Chat GPT is a better writer. It gives more words to its solution, but both have hallucinations. Now, what are these hallucinations? They are not on drugs. They are called hallucinations. So what is this hallucination? I'll explain you. So if there is a GPT or an AI chatbot, and if you ask the AI chatbot a particular question, and if it doesn't have the reference to an answer or a date or a place, it will make a fictitious date or a fictitious place and tell you, suppose I asked the chatbot on what date smallpox vaccine was made. Suppose it's not there in their database. It will come out, it was made in New Delhi on July 23rd. You immediately come to know this bugger has hallucinated. So you again refresh the command, you start saying that you please go back to the reference and give you the true data, this is false. So this is what a hallucination is. So this is what you have to be careful about. When you start using a chatbot, you should know what you have to accept and reject. Because if you start accepting the wrong facts, you will be misled. And you will be coming out with wrong solutions. I'll tell you at the end of the presentation. So just quickly summarizing, Google Bard, pros and cons. Pros, Bard has an internet access. Bard is better at surfacing relevant information, including images from the Google search. More user-friendly, nicely formatted human-like response. Bard is prone to hallucination. Every AI chatbot is. Let me tell you. Sources are not always reliable and should be fact checked. Absolutely keep that in mind always. Bard provides a fairly isolated experience. It doesn't have plugins. So you can't book your vacation through Bard at the moment. Maybe it will evolve and bring out a third-party plugin, maybe free of cost for us to use. ChatGPT, better at generating text. You must have used DOS. If you know DOS, it works like a DOS language. You know, it keeps on giving you text in a very bland fashion, and it makes you. It has an ability to share conversations with the others because you can just copy paste and send it across. And it has multiple plugins. Very important part, which makes your life very easy. And it has now started having access. The cons are it has started now having access to the internet, but it's very slow at the moment. That particular program is called ChatGPT Plus. Go ahead and use it, but you will, when you want the internet resources, you will love Bard doing that. You know, and so these ChatGPT responses can become very, very lengthy. You have to cut them short. You know, I wrote some command yesterday and it started giving me a data which is a fictitious data. And I told them, boss, this is fictitious. Please give me real life examples. And it came down and filtered its results and it gave me the correct data. So it does have hallucinations. Keep that in mind for any chatbot. Again and again, I'm telling you, the best AI productive tools by category. The best chatbots are ChatGPT, Bard, Hugging Chat. You can just click a photograph of this. There are multiple of them. You can use any of them. I simply love Del 2, you know, where you can write a text and it makes an image out of it. You know, if I write, kindly make a painting out of a pathologist looking into a microscope. And make a beautiful painting out of it. You can store it on your desktop. So that it happens in seconds. You know, there are many of them. You can write your own PowerPoint presentation by Slides Go. Please go and try it. It's free, but downloading is not. So you can actually see your presentation and the material in it. It's called Slides Go. So many of them. There are 3D modeling for protein structures. You can make a chatbot by automation, by Zapier. So let's come down to AI chatbots in healthcare. What are the advantages? Remember, this is a basic presentation. I'm not going into details of all the prompts, all the tools, all the plugins being used in healthcare. It's a second lecture. Hopefully, we'll have it shortly. And it's a good lengthy lecture. So, and it's very interesting. But just to highlight these points, advantages, it gives you an enhanced diagnostic accuracy, faster turnaround time, 24/7 availability, reduction in human error, and support for resource-trained areas. That is why we have started getting dependent on these AI chatbots. It covers all the areas where we feel deficiencies throughout. So if we talk about enhanced diagnostic accuracy, there is a AI program or a chatbot which is called IBM Watson for oncology. You must have known this. This reads your tumor diagnosis, the staging and the grading, and can give you a predictive medication depending upon your diagnosis and your presentation and the grading and staging of the tumor. It does it beautifully. It's called IBM Watson for oncology. Path AI is another such developer which has come out with AI Site, IBD Explorer, Path Explorer. What is AI Site? It's like a digital pathology. You just feed in an image, it tells you where the tumor is. As simple as that. It is learned. Beautiful program, AI Site. Go to the website. There is an IBD Explorer where it will tell you the grades of ulcerative colitis, looking into the microenvironments. Path Explorer will tell you the grade of the tumor or the outcome of the tumor, reading the microenvironment. That's what the Path Explorer does. And this is all developed by Path here. DeepMind, another beautiful developer who has come out with AlphaFold 2. This actually analyzes the three-dimensional structure of the protein to make you understand some diseases like Alzheimer's and bring out newer medication as per the 3D structure of the protein. So this is doing wonders, coming out with, going hand in hand with pharmaceutical to bring out more and more drugs, which are more effective. Others, you can just go onto their website and see this buoy health care. Actually, you feed in your reports, your history sheet. It'll go for a symptom checker and it'll tell you what your diagnosis is, or it'll give you a differential diagnosis. It's called buoy healthcare, and there are many of them. There is a Your MD, which is always there to listen to your symptoms and tell you what you might be suffering from. So these are some of the AI chatbots which are being used commonly in healthcare. There are many of them. I'll cover them in the second part. Now, what are the disadvantages? The disadvantages are basically it has a limited contextual understanding. What do you mean by that? So if a patient, suppose, says, I got a chest pain and vomiting, now the AI chatbot reads this and whatever data it has in the back end and comes out with a diagnosis that you've got heartburn, please go and take an antacid. So as doctors, we will not stop there. We will go deeper and deeper till we come down, start investigating, and then we come down to a diagnosis. This is actually a limitation of contextual understanding, or a complex medical language is not being understood by the AI chatbot. Its inability to handle rare cases, because as you know, these are not the number of cases where they have in their learning to go and refer to such rare cases so that the diagnosis can be brought in. And of course, legal and ethical concerns. If something goes wrong, who's liable here? If the patient is misdiagnosed, who's liable? There are some ethical issues regarding that. There are some legal constraints regarding that. And of course, the issue of data privacy and security is always there. It has always remained there. It will become bigger and bigger with all these data being shared among the internet and among the different AI chatbots. So we need to be very, very specific about the privacy and the security of this data privacy and security. And then the whole chatbot example is dependent on training data. So the training data, if it is small, you will get limited results. If it is big, you will get more specific and better results. So there is a dependency on the training data. So the potential risk as per these disadvantages are basically delay in proper treatment, as I told you, inaccurate self-medication, misdiagnosis. The AI chatbot can give you misdiagnosis. So how do you address such issues? The developer should make visible the transparent limitations or enhance the data training, and they should make the AI chatbot in collaboration with healthcare professionals, and they should also refer the complex cases to professionals. So please remember, we are here to stay. We are not going anywhere. Very important part we have to play. So please remember that the developer has to share all the healthcare knowledge with you, and you have to do the fact checking and bring out the solution. Conclusion is that the AI chatbots offer significant advantage in pathology diagnosis, augmenting medical professional capabilities. However, the limitations and challenges must be carefully addressed and monitored to ensure safe and effective implementation in healthcare systems. Very important. You are the boss who decides what is correct and what is not when it comes out to the solutions given by the AI chatbot. Very important. Again, I tell you, we are here to stay. So the take-home message is AI will not replace pathologists, but we need to learn to adapt to the changing diagnostics. So it will not replace a pathologist, but we also need to learn how to adapt to this changing field which we are incorporating. So once a new technology rolls over you, if you're not part of the streamroller, you are a part of the road. Of course, absolutely right. So let's sit on the steamroller and decide where it goes. And of course, we still have the emotions. We always get the jokes, but they don't. Thank God, we always get the jokes. So thank you very much. And I will give you a short example of about 1 minute of how ChatGPT works by giving a prompt. So you will you please mute the phones? I will share my screen, some other screen. Yeah. So this is the screen which you get. You go into login. When you log in a ChatGPT, it is available on chat.openai.com. So I will use in my username, my password, and it continues. Now, on the left, you start getting the history of AI chatbot, your chats with the ChatGPT. These are some of the positives of ChatGPT. ChatGPT 4 is locked because it is paid. 3.5 is for free version. You can use that. And I will just ask ChatGPT, please make a PowerPoint presentation on importance of pathologists in healthcare industry. Now I press enter. Here it comes. You see how quick they are. And now this is going on. Absolutely right. I agree to all these points. And it summarizes at the end. You can copy this, paste it. So it'll ask you for questions. You can say, make a slide design for a slide deck according to this chat for PowerPoint. So see, it started making a PowerPoint slide set. It will tell you what you have to include. You can also tell it to include some images. But what I do normally is I say, write VB is the Visual Basic Code for this PowerPoint See, we started writing a whole Visual Basic Code. Very simple. Just copy this code from here, take it to a PowerPoint, insert in a module, save it, you have a ready PowerPoint presentation on importance of pathologists in healthcare. As simple as that. It has taken seconds to make a 40-slide PowerPoint presentation. It can also tell you to add images, to tell how many slides you want, filter out the content and everything. So that was indeed everything. So any questions, you can put it in the chat before I conclude my presentation. We will go into the detailed presentation at the end of it. Thank you so much. Thank you, Dr. Prashant.
Thank you, sir.
Thank you, Dr. Rajan,
It was a
sir,
nice...
Yeah, please, Dr. Prashant, please go ahead.
Thank you, sir. It was a very nice presentation. You have very explained each and everything very nicely, and people are also responding. Thanks a lot, sir.
On behalf of everyone, we thank Dr. Rajan Verma for very informative presentation. The next presenter would be Dr. Pranav Dey. However, we have Dr. Santosh, sir, who was not able to join earlier. So I would request him to say a few words before we go to Dr. Pranav Dey. Dr. Santosh. Dr. Santosh, sir, we can see you.
Okay, yeah.
You can start.
Okay. Thank you, Dr. Rajan Verma, sir, for your very informative and simplified presentation. Sorry, there was some connectivity problem. Good evening, ladies and gentlemen. Myself, Dr. Santosh Kumar. As the president of the Association of Practicing Pathologists, Haryana State, it gives me immense pleasure to welcome you all to this highly anticipated webinar on the use of artificial intelligence in pathology. Our association, APP Haryana, is 14 years old society, which has been working for welfare of pathologists in our state. We are more than 250 pathologists in this association, and we have been organizing regular conferences and CMEs in different medical colleges of Haryana since last 14 years. Today marks a momentous occasion where we gather to explore the convergence of artificial intelligence and our novel field of pathology. In this digital era, where advancements are rapid and far-reaching, embracing artificial intelligence in pathology is not just an option, but a necessity to provide faster and more accurate diagnosis and personalized treatment plans to our patients. I would like to express my heartfelt gratitude to our esteemed speakers who have graciously accepted our invitation and are here to share their expertise and knowledge with us. Each one of them is a luminary in their respective area of pathology and AI, and their contributions have paved the way for groundbreaking advancements in our field. Now, I am honored to welcome Dr. Pranav Dey, a distinguished cytopathologist. Dr. Pranav Dey from PGI Chandigarh will be shedding light on the cutting-edge application of AI in the analysis of cellular specimens such as fine needle aspirates and body fluids, and its role in facilitating precise and efficient diagnosis. A warm welcome to Dr. Sonal Jain, a renowned hematologist, who will share insight on the integration of AI in interpretation of blood smears, bone marrow aspirates, and its potential impact on the field of hematology. We also welcome Dr. Nalini Bansal, who is an eminent histopathologist. Dr. Nalini will enlighten us on how artificial intelligence is revolutionizing the interpretation of histopathology, aiding in accurate diagnosis, and providing personalized treatment options. Ladies and gentlemen, this webinar represents a moment of convergence where two powerful realms, pathology and artificial intelligence, join forces to drive the future of healthcare. Let us use this opportunity to engage in meaningful discussion, exchange ideas, and foster collaborations that will drive innovation in our field. It is through such dynamic interactions that we can collectively harness the potential of AI to create a brighter future for pathology and, most importantly, for well-being of our patients. Before I conclude my welcome address, I extend my heartfelt appreciation to the organizing committee, especially our APP Haryana Secretary, Dr. Prashant Gupta, and our sponsor, Mindray team, for their tireless effort in curating this webinar. I also extend my gratitude to all the delegates and attendees who have made this event possible. Let us embark on this enlightening journey together as we explore the limitless possibilities that AI holds for our field. I encourage each one of you to actively participate, engage in fruitful discussions, and collaborate for the betterment of pathology and patient outcomes. Seeing the vast response from participants, we would definitely like to continue with another CME on in-depth knowledge of AI within a month or two. Thank you for being a part of this momentous webinar, and I wish you all an enlightening and rewarding experience. Thank you all.
Thank you, Dr. Santosh, for your kind words. Now we would invite Dr. Pranav Dey to start his presentation. Dr. Pranav Dey, over to you. I'll stop sharing.
Am I visible?
You're audible and visible both, sir. Please go ahead.
Okay. Good evening. Thanks to the organizer to call me in this CME. I think I have no space for details because my previous speaker for complete 1 hour extensively has discussed many things. So I will be extremely brief and I will keep my time. If my time exceeds more than 25 minutes, please stop me. Artificial neural network in cytology. This, suppose not 2057, you wake up in the morning and see the newspaper. A consultant robot posts vacant in the pathology, and there is lot of protest going on of the pathologists because their job is over. Is it possible? When 20 years before I showed these slides, everybody was laughing, but I don't think now you will take it so lightly as a joke. And here we need really in-depth discussion of artificial neural network. I will be brief and I will speak in two areas. One is basics of artificial neural network and another is application. Basics he has covered, so I will be as brief as possible. Then I will go directly of application and challenges. Now, first revolution in the pathology area. I am a pathologist. I will discuss mainly pathology, not any commercial areas. I will not go. First is the immunocytochemistry. That was a very important revolution in pathology. Then molecular biology. It is still undergoing on, under process. And then came artificial intelligence. In fact, it is the third important revolution in pathology. Whether you accept it or not, it is knocking in your door. First, I'll briefly say about the history. History actually long back it started. 1890, then 1943, Mack, Kulak, and Pitts introduced Perfecton machine. Then Rosenblatt, they prepared this Percepton, but the whole things will be injustice if you don't speak about the Alan Turing. Alan Turing was the father of artificial intelligence. He was in the British spy system, and with the help of artificial intelligence, he uncoded many of the German message, but he was unrecognized. British police arrested him as he was gay. He was punished and he cannot tolerate it. He committed suicide by eating poisonous apple. Nobody knew his name for many, many years because he was in the spy system. Then suddenly it was revealed that he is the person who discovered so many things. The Apple computer, they have put their logo, a half-eaten apple, poisonous apple he ate. So half eaten poisonous apple. So he was the father of artificial intelligence. And you know, he has described that. Why neural network? Because it simulates neuron. Neuron gets information. So here there are nodes which gets information. And this information is processed in the nodes. It is going to the next node. And so a neural network, what it is? It is a massive parallel distributed processor, many nodes, and it resembles in brain in two aspects. First, knowledge is acquired by the network from the environment, and second, there is a synaptic connection, and more it learns, the connection becomes stronger and weighted changes. So if you see that this is the mathematical calculation, suppose you want to see that a patient of this pathology specimen will go for early relapse or not. Suppose he had multiple inputs. Suppose this is the mitosis. Mitosis will be X1. The number of mitosis may be 2, 3, 4. So that is the numerical number, and the machine gives or nodes gives the weightage of the mitosis. May be much more weightage, tumor size different weightage. So each time you give the training, this weightage changes. So this node gets information sigma wi is xi. Then if it exceeds certain points, firing occurs. And these are the different activation function. I use mainly sigmoid neuronal unit function and rectified linear unit ReLU in deep learning. So you need not to know now in details these things. And he has already discussed about the supervised learning, unsupervised learning, and reinforcement learning. So this you have to give training. Supervised learning, what? If this is unsupervised learning, here computer doesn't know what is what. It is unlabeled data. It divides this unlabeled data. And unsupervised learning, here we say this is dark, this is not dark. And we give the training. After that, we give images of one sample and it identifies it is dark. So malignant cells you give, benign cells you give the training, and it identifies which is benign, which is malignant. This is supervised learning. Reinforcement learning we don't want to discuss. So this machine modes is the back propagation learning. Here the input is there. Hidden layer, the input is processed. You get the output. So it may be your target output, or it may be away from the target output. So error will be target output minus the output which you got, the mistake. So it identifies the weightage according to the mistake. And by repeated iterations, it adjusts the weight so that error becomes minimum. This is the equation which he uses. So this is a multi-layer perceptron architecture. You see, from the environment, this data you have to give. You have to give the data first thing. This is the input nodes. Then there is a black box where all the nodes come, and here the weightage is given, nodes information is processed and give it to the final result. That is the output node. So black box is the hidden node. We do not know what weightage is given in which node or which input. So the weightage changes in the time of training. Now the steps, what I follow the steps. First thing, data processing. We accumulate the data. Training data is divided in 3 sets. First training set, it gives the training, and test set is the final. Validation set, you maintains the topology of the data. Then comes the other steps. Other steps are the neural network architecture you have to make, and then the training is given, and ultimately after the training, you give the network model to the test set data and see how it works. So basically, these are the steps. And accuracy, you identify about the true positive, we all know, true negative, false positive, false negative, and receiver operating curve, you have to make it, and area under the curve is more when you are more successful. That identifies how the machine works. You have the model, but you have to identify whether the model is working or not. These are the different neural network. I have used mainly backpropagation artificial neural network, and in the deep neural network, convolutional neural network. This we have worked on. Now, when to use artificial neural network? You should not use it randomly. When you have a problem, it's a complex problem. You cannot solve it. And other methods have not produced satisfactory result. Or if you use that artificial neural network model, it will be a great help of the human beings and economically also. So in this area, you have to select. You cannot use it randomly. Now, let's see application. I will not go to anybody's things. I will only tell you what we have done. What we have done. First thing, cervical smear, I have not done the work on cervical smear, but I have to mention because it was the first commercial ANN model PAPNet system. It was highly successful and with high accuracy, but unfortunately, the company was bankrupt, it was sold, and it was stopped. There is no FDI approved cervical smear screening program till now. Forget about the GPT, chat GPT, bot, everything, but there is no FDI approved ANN model till now in cervical smear. Breast. I have seen that time, it was about many years before, 15, 16 years, when we have faced that problem to differentiate ductal and lobular carcinoma of the breast. And we used a ANN model, we built an ANN model on the basis of cytological features and nuclear morphometric data. It successfully identified benign ductal and lobular carcinoma cases. Similarly, we have used it in identifying benign and malignant cells in the cytology smear by utilizing this nuclear morphometric data, densitometric data, and chromatin textural features. It was a successful model. Many people have done different works on the ANN of breast, but nowadays you hardly will see the cytology of breast, and so ANN was discouraged. Thyroid, we have taken problematic area, follicular adenoma versus carcinoma. Very difficult or not possible on cytology. And we took that challenge. We have taken that all the data, morphometric data, different measurement data, gray value and integrated gray value, and then textural features, and make the model which identified which one is follicular adenoma, which was follicular carcinoma. That was a very successful model. Then recently, about 6 months before, we have worked on another model that is the most challenging area in thyroid. AUS means atypical cells and flush, follicular lesion of undetermined significance. Which one will be benign, which one malignant? From the cytology smear, we identified which one benign, which one malignant. We had the all follow-up data, histopathology data, and it successfully identified with 99% accuracy which AUS on cytology will be benign, which is malignant. It has a very important management applications. And various other people have worked also, but in this issue, only Shapiro worked 2007, but not in AUS area. He identified follicular adenoma and carcinoma successfully. Then in effusion cytology, it is a challenge to identify benign and malignant cells. And similarly, we built an artificial neural network model which identified benign and malignant cells in effusion cytology. And there are other studies, very few studies there. In urine cytology, we felt that challenge of identifying atypical urothelial cells, low-grade and high-grade urothelial carcinoma. Here also, we built one model. We extracted the data with the help of ImageJ. Yes, we all used, all these cases we used ImageJ software, which is a free software. You can do yourself also. From the image we identified, and we made this model, which was a very successful model of identifying no malignancy, low-grade urothelial and high-grade urothelial carcinoma. It was a very successful model, and all this work was published in different journals. And then in salivary gland also we have used ANN model to identify adenoid cystic carcinoma versus pleomorphic adenoma, which is often a problem. Then in effusion cytology, in cervical cytology, we have seen that agas cases, atypical glandular cells, unknown significance. Some is benign, some malignant. So we took all the data from the cell, their cell shape, size, textural features, and identified successfully which one is benign, which one is malignant agas. Then we can summarize that in cytology, it can help classification of the tumor, grading of the tumor, diagnosis, even prognostic assessment we have done. In a case of a group of CML cases, we identified with this which one will go blast crisis early, which one will be late, with the help of ANN model, which was published about 15 years before. And then management also you can apply. So these are the very basic 5 areas where you can use, we have used in ANN. But there were certain limitations. If you see that it takes a long time to extract morphometric data, and it needs expert, and data selection may be biased. Which cells you select, which cells you want to select, that is your bias. But we started about 17, 16 years before, when there was no deep learning, and ANN was most ignorant area. Today everybody is saying ANN. That time, if you say ANN, you will be discarded from the pathology team. And the thing has changed. Now there is deep learning. It has come few years before only. And what it does automatic feature extraction. No need of technical knowledge. The machine itself, computer itself takes the data and it identifies which cells benign, which malignant. And it can handle large amount of data. You see, this small image has 540 to 540 pixels, huge amount of pixels, few lakhs. And each of the pixel area, if you take as nodes of neurons, till now, no supercomputer can do that. Means in this civilization, till now. So it was impossible to work. I faced this problem repeatedly when we are extracting the data from the images. Then it comes deep learning. How it works? Actually, deep learning, the first is the convolutions. We use filter on the images and it makes the image small. Now it is not the time to discuss because we have limited amount of time, but this filter, we use it. The next stage is activation. This is RELU. I have already told. this activation function, we use it. Then pulling the layer, the small images becomes much smaller images with the help of pulling layer. So then ultimately, last stage, we have to make that classical artificial neural network, which I've discussed just now. So many years we have done. So this image will be very small, but it will keep all the features of this image. So this is deep learning. And recently we published last week, few days before, that on effusion cytology, with benign and malignant cases, we give the computer the images, and computer successfully identified which are the benign, which are the malignant images. So this is our model, which we used it. And this is that things you see that in repeated steps of deep learning, these bigger images become smaller and smaller and smaller, but it identified that which one is benign, which is malignant. So our model was a very successful model, which was published immediately in Cytopathology. This model works very rapidly, and there is no bias of cell selection. And only thing, you have to make the model. But there are certain problems of ANN, as my previous speaker highlighted. First is approval. If you see that he has told so many ChatGPT, bot, and Googles, but none of them are approved by regulatory agencies. Approval of regulatory agencies is needed for your diagnostic neural network model. And FDI thinks that ANN is a highest risk class 3 devices which should not be approved. So this is one problem. Second thing is that we do not know about the black box, what is going on hidden layer. We have no control. How it gives weightage, we do not know. That is a great problem. That's why it is known as black box. It is black to us. And third thing is that you give the diagnosis. Without human subject, a decision cannot be given to the patient. This is the European Union guidelines. I do not know that in India there is some law there or not, but in Europe, law is very strict. So you cannot give your diagnosis based solely on the basis of automation. But I think law will change in course of time. So this is a summarization. You need large amount of data. Go to ChatGPT and do your work. No, you cannot do that things. You need very, very large amount of data, number one. And data storage is one of the problem, number two. Number three, I told you, no control on the black box. Medical legal issue. If the computer gives the wrong, your system gives the wrong, who will take the brunt? Who will be punished? And then data protection. Your data may be used by somebody else. And data is, data is the gold, more than gold. So you cannot share all the times your data. You do not know how they will use it. So these are the various problems. And then computational pathology is knocking in your door, where WSI or whole slide imaging data you get, clinical data you get, various biomarkers you get, immunocytochemistry data and genomic data, you take it all together, make your own artificial neural network model, and this will give personalized management of each patient from this data. And event prediction also you can do. So what is my role? What will be your role? Is it that our job is gone? No. Our role will be different. we will integrate the data. We will help to build up the algorithm preparation for diagnosis, management, and everything. We will analyze the data, evaluate it, and will rectify the model. And continuously validation is needed. So our job is not gone. Our job will remain, but our role will be different. And if you see that, as he has highlighted, there is a cloud storage for data. High-speed network is there. High-performance CPU there. So in the global data will be collected in future, and laboratories can give their data for the diagnosis, treatment, and follow-up. But again, it comes data protection. Then different countries have different law. So until and unless whole globe is only one village, that is a problem. In fact, there is problem. It is not that so easy to use artificial neural network. It has to cross many, many barriers. And so our role will be different. Data scientists will be there at complete team who will help to design and architect the data. Engineer will make the hardware and software, and this is our role that I have already told. So lastly, I'll say that a journey of 1,000 miles begins with a single step. Now it is high time to understand the artificial neural network. What is the fault of artificial neural network? What is the potential of this neural network, and how to use this giant? You must be knowing that story, that if you cannot use that giant, it will kill you. So the technology should be in your hand, and you will use it in proper way and for the benefit of your pathology society and overall the civilization. Thank you very much.
Thank you, Dr. Pranav Dey, for a very informative presentation and sharing your experience with all the guests. I'm sure they would be enlightened and they would understand the AI in pathology much better today onwards. I must thank you for this. Now we have our next speaker, Dr. Sonal Jain, and she will be speaking on Dr. Sonal Jain is DM Hematopathology, and she is also MD of Art of Healing Cancer of Ashicare. She is ex-head hematology Dr. Dan's lab, as well as ex-head hematology from Rajiv Gandhi Cancer Institute and Research Center. I invite Dr. Sonal Jain for her presentation. Dr. Sonal Jain, over to you.
Thank you, Dr. Prashant, Dr. Santosh, entire APP Haryana team for giving me the opportunity to share my experience of this new kid on the block, which is knocking at our doors, that is artificial intelligence in hematology. So I begin with this heading in 2021 leading journal, which anticipates that artificial intelligence might disrupt diagnostics in hematology in the near future. And in less than 2 years, that is 2023, a leading journal reviews artificial intelligence in hematological diagnostics, in which it covers essentially that in every subspecialty, every field of hematology, AI has had its inroads. And by the end of around 20-25 minutes, you should be able to decide whether it is a game changer or just a gadget in our hands. So I'll begin with artificial intelligence in cytomorphology. So AI-assisted peripheral smear reporting, which is very much there commercially available today. So AI-assisted peripheral smear reporting broadly has 2 steps. The first step is digitization of that stained glass slide using slide scanners. Second step is the data-driven analysis of these digitized glass slides. So there are n number of digital slide scanners. Some of these are manual, some are automated, some of the key players are mentioned here. The specifications of these slide scanners, which are optimal for peripheral smear or hematology slides, is different from the ones that are used for cytopathology and histopathology, akin to the way we see our slides under the microscope. We don't use the same optics for the two. This is followed by AI-driven analysis of the digital images. So there's, my previous colleagues have already spoken intensively about AI models. So these AI models for peripheral smear reporting, they are trained to detect monolayer of the sample from the Romanovsky stained peripheral smear. Once it has identified the monolayer, the individual images are captured, and these captured images are further analyzed to characterize the cells based on various characteristics. We have already learned a lot about how these AI models learn from different set of images. So workflow from a digital slide scanner to a AI-driven reporting. The step one is a microscope is replaced by a digital slide scanner. This slide scanner processes the slide, followed by image capture, followed by pre-classification of pre-characterization by AI-driven analytical softwares. And this pre-characterized cells are further reviewed by pathologists, followed by review and verification of this final edited, reviewed version. So this is from one of the service providers or one of the players in the market. So as we have learned from the previous presentations, first the image is captured. Acquired image, its features are extracted by various type of neural networks, and the output that these neural networks give is a class prediction. They put this particular image into one of these categories. So now which categories, the number of these categories and the specific subtypes depends upon, it's different for different softwares, different service providers, because their training data sets are different. So this is the categories of one of the players. Similarly, the RBCs, a similar neural network based characterization of the cells is done by the AI-driven analysis. So, and so once this output, this image has been acquired, and then the output that you get looks somewhat like this. So at the top, you can see that there you have different icons for WBCs, RBCs, platelets, microscopic view, and so on. So you click on one of these icons and you get a detailed split up of the different. So the service provider gives these categories, and what you see on the right window is a neutrophil subset. So you can see all the 56 neutrophils in one window. This is from another player. The categories of the cells in which it can characterize is different because their training set, their validation set, and their test set is not the same, and that's why the cell categories are not the same. So on the left side is the categories that another service provider gives. So moving on to RBCs, these AI softwares can characterize red cells according to their sizes, small, microsites, normos, macros, and also based on their shapes, that's the next RBCs poikilocytes. Similarly, the platelet window, where it can it characterize them as according to their shapes, and also it shows platelet clumps window as well. And last but not the least, this is the microscopic view. That is you will see on your laptop or on your device the smear the way you see it under your microscope. So this is the microscopic view. And this is the summary. This is a summary after you have reviewed and recharacterized. Just reiteration that each of the categories that the software has already given you, you can go to go to any of these and recharacterize them. If you feel a monocyte has been put into a lymphocyte, or a lymphocyte has gone into a monocyte, or a blast has been put into a monocyte window, you can go back to each individual cell and recharacterize it. So this final report is generated after the pathologist has reviewed each and every image that it wants to. So what are the strengths and advantages of this as digital microscopy assisted by an AI versus a manual glass slide microscopy and reporting under a microscope? So I'll first touch upon the strengths and advantages. So we come to WBC abnormalities. It sorts different cell types, so which enables us to do a quick review of large number of cells. Like we saw that if you click on the neutrophils, and if we have scans of 400 neutrophils, you see all those 400 neutrophils in much shorter amount of time, which otherwise would be possible when you're looking at a smear which is full of all kinds of cells, and digging out 400 neutrophils won't be that easy. So any abnormality there, toxic granules or pseudopelvic abnormality or hypersegmentation, is unlikely to be missed here. So this becomes extremely important when the cell number is less, when the cell count is less. I'll show you an example in a while. Similarly, for RBCs, if there are uncommon a few abnormal cells like spherocytes, it may be easier. It may be is the term I'm mentioning because there are pitfalls there, which I'll also cover up. And microscopic view allows a whole slide view, which is similar to the way we are seeing it under a microscope. So this is the advantage that's there with digital. So the digitization of the slide allows a huge digital network that can be used. So using that digital network, remote review, collaborations, and expert opinions is possible like never before. Just reiterating what I said, that each of these, you click on the lymphocytes, you can see all the lymphocytes. So if it's a CLPD or CLL or hairy cell leukemia, stuff like that, you have all those cells in one window, and it's a quick review is possible. Similarly, all of these cell categories. Just that's a quick case, a real-time case of a middle-aged man presented with a CBC was done, which showed severe pancytopenia. So in severe pancytopenia, anyways, a smear would always be prepared and reviewed under a microscope. But what advantage the AI digitization, digital network offers? So there were only 22 slides that the scanner could see and AI could dig out. And out of these 22 cells, it showed me that there were 6% atypical cells. And on picking up these atypical cells, these are the images that I saw. And so we can make out that these are abnormal promyelocytes. So this patient had acute promyelocytic leukemia and it had severe leukopenia. And since this was a remote review, I was doing this review at 10:30 p.m. in the night. Now, having said that, in such severe cytopenias, it may be sometimes difficult to identify this less number of atypical cells. Secondly, APML, if not diagnosed in time, can be rapidly fatal. And a diagnosis which is a swift diagnosis is a lifesaver in this particular condition. Then limitations, can it do all on its own? I mean, they can characterize all the cells, all RBCs, WBCs, and platelets. So, is the game over for us? So I'll just quickly take you through a few cases. So this was labeled as atypical cells of blast window. But what are these? This was a megaloblastic anemia, and what was there was a big cell with cabo rings in there. So this is the limitation of the data set. The data set, the AI, the neural network has not been shown cabo rings, and hasn't been given a separate category. So the AI put it into any closest category it could. The second case is showing 20 NRBs. As an opening of this window, to my surprise, all of these were neutrophils. It could not identify it as neutrophil because these were hypolobated neutrophils. They were dysplastic neutrophils. So again, the data set is not trained for dysplastic neutrophils. So it doesn't know the features which are different from an NRBC. The closest cell it could find was a nucleated RBC because it was taught that all the lobated neutrophils it has seen. Another case, an 18% atypical cells. What are these? All of these cells? These are all monocytes. And since the sample is not that perfect or not that new, so the monocytes are not the perfect monocytes. Another example, this window shows me 18% microcytes. But what do I see there? These are non-hemoglobinized cells which are smaller. So to our knowledge, we know these are spherocytes. These are not microcytic hypochromic cells which are significant microcytes in the smear. And lastly, the platelets. So platelets are nuanced under the microscope also. So here the AI also does more errors. It is saying 6 platelet clumps, but what are these clumps? What it is labeling as clumps? It is labeling the degenerated neutrophils, the separated lobes it is identifying as platelet clumps. Similarly, at the bottom, it is showing 5 giant platelets. These again are degenerated lobated neutrophils. As separated fragments, it is counting as giant platelets. So what does it bring to us? So it's basically it learns from experience. That is the data set, the training set, validation sets, and the different sets that we have seen in the previous presentation. So what does it mean? So what is the difference between a first-year pathology resident and a third-year resident? And a difference between a resident and a senior consultant or a subject expert? So interestingly, a resident graduates from first year to a third year resident and over time into an subject expert. But the data sets which are based on image analysis, the image analysis software, they don't, once they are into the commercial field, they do not graduate from a first year resident to a third year resident. Their learning is fixed there. They come up there until unless they are given more training sets, they will not learn, they will not evolve. So accuracy, precision is of any of the neural networks is dependent on the inputs and regional biases. So a software which is designed in the US or Kenya or any other part of the world may not be applicable to other parts of the world because there are racial differences. Now, so this is about the smear. What about other cytomorphology aspects of hematology? Another big chunk is the bone marrow aspirate smears. Now, bone marrow aspirate smears is a little more difficult game because there are many features to a bone marrow aspirate smear that one analyzes. There's the fragments and the n number of cells. But yes, it's being done. And there are platforms available which can characterize different cell types, as you can see over here. And ultimately, the n number of categories that it can characterize bone marrow cells are the sub-commercial. Very soon there will be, and some will be available, the software which can analyze bone marrow aspirate smears as well. Now, what about more advanced hematological tests? Now, so far we have understood that building an AI software is easier for anything which is already digitized. So a lot of laboratory data is already a computer generated data is in the computers. So one big field is highly specialized assay, that is flow cytometry. And to my mind, it would be a dedicated work on building AIs around it would be much easier than automating building AI around cytomorphology, because it's inherently a computer generated thing. And they are building an AI for the most complex flow assay, which is MRD diagnostics. It's interesting where the future will take us. Cytogenetics, as we all know, it's integral part of hematology diagnostics, but it is at the same time highly complex. It's the chromosome banding is there, and the most difficult part is then segmenting it into. So all of this is now can be done by AI softwares, which is to prepare the metaphases, and rest of the work is done by AI and gives you a decent cytogenetics report. Now, genomic revolution, what it has led to, it has revolutionized hematology care more than anything else in the diagnostics. And every hematological malignancy has to be assisted by molecular data. So next generation sequencing means a huge amount of data. Now, human brain is limited in analysis of these big data sets. So this is where it's only the AI models which can be trained to build predictive models, precision medicine, and new drug discovery, because this huge amount of bioinformatics data integrated with simpler but most doctor dependent, the more user dependent tools, that is cytomorphology, etc. All of this integration can be beautifully done by AI models, and that's what the most of the focus historically has been on. So outcome prediction, diagnosis, integrating this data from different tests into one and coming up with prognostic scores, treatment decisions, and stuff like that. So coming back to where we started, artificial intelligence in hematology, is it hype, a gadget, or really a game changer? So looking at it, digital networking assisted by AI can be instrumental in looking after medical deserts, which means that in our last vacation, we went to Sariska National Reserve. And this Sariska National Reserve, deep in the forest, there were some 20 families that were living. And all of them had mobile phones with limited access to drinking water and electricity, but they all had mobile phones with them. At these places, there never be a hospital, a highly specialized healthcare facility that can be built up. Neither it is cost effective. So looking after such medical deserts is possible only by digital networking and AI tools. And if used judiciously, this is the only way we can provide equitable healthcare for all. And a very important part is that it can minimize laboratory errors due to sample transportation. So what do I understand from this? So a CBC sample, which is drawn at one place and driven to a referral center, which is taking 24 hours or more, even less, is better, or having a CBC sample drawn, making a smear, staining it, and then transferring the images, which will be less error prone. It's for us to think about. And it allows collaborations like never before. It gives power in the hands of everybody, the power of the world in everybody's hand. Anybody sitting anywhere can take opinions, can ask for a review. Many a times, all of us have strengths, but all of us do sometimes feel that agar ye slide kisi ko dikha sakta. So with that, with this digital network allows everybody to have all the power in his laptop, in his hands, and deliver healthcare to that patient sitting right in front like never before. So, and interestingly, for hematology, a CBC is the starting point of blood disorders. And a CBC comes to a pathologist before it goes to anybody else. Having that diagnostic power is really immense. So this is really, I feel, a powerful tool to provide any diagnosis to everybody. And it allows us bigger strides in innovations, research, and personalized medicine. So what does it? So how do I feel? It's just my personal opinion. Artificial intelligence, is it a competitor or it is a tool in the hands of supreme human intellect? I say supreme because human is created by that superpower, and we humans created artificial intellect. So first of all, when we are saying that we can be replaced, we are questioning our own self, that we are the supremest creation of the God. Now we have autopilots. So are these autopilots supervised by a common man? No. Human pilots supervises autopilots. And what has it led to? Safer flights. We have ADAS, Advanced Driver Assistance System. So does that ADAS vehicle driven by a non-driver, one who doesn't know how to drive? No. It will be driven by best drivers. And what has it led to? Safer road travels. But can that ADAS do everything on its own? So all the roads are not same. We have gaddhas, we have stones, we have kacha rasta, we have pakka rastas. So we need best drivers to be assisting and supervising these ADAS. So artificial intelligence, it should be handled by us, which is truly supreme human intellect, so that it can deliver what it should, a better healthcare, equitable healthcare for all. Thank you.
Thank you, Dr. Sonal Jain, for your very informative presentation and its application in hematology. So I'm sure this would have helped all the guests. Thank you for the presentation. Now we move to the last presentation from for AI, Dr. Nalini Bansal. Dr. Nalini Bansal, just a moment. Dr. Nalini Bansal Gupta is MD in Pathology, Gold Medalist, FRC Path in Histopathology. And she is constantly involved in various academic activities and has over 85 publications in histopathology to her credit. She is also an associate editorial board member of Indian Journal of Pathology and Microbiology, IJPM. She is a reviewer of various journals and pathology outline websites. So we welcome Dr. Nalini Bansal. Dr. Nalini, over to you.
Yeah, thank you so much, Varun. So stop sharing. I think we'll share the screen now. I think it's really exhaustive, and it is definitely a very good session about AI, because these are the things that will come to our mind off and on. So with this, we'll take a deep breath and we'll dive into the world of histopathology, in which AI is again very important. So this is what we'll be dealing with. So is this the road ahead? Yes, definitely. I would say this is the road ahead. And we just cannot get away by saying that AI would have problems. AI is definitely going to supplement the pathologist in a lot many ways. So this is how we will be seeing it further. So we'll be discussing each one of these components one by one. The outlines of this session would be, we'll be discussing about the digital pathology, the digital pathology role for AI, how to do digital pathology, why AI in histopathology, how to do AI, what are the uses of AI, and what are the problems. These have already been discussed, so these we are going to skip. So first and the foremost thing before we enter or dive into a artificial intelligence world is you should know, or you should have in hand, that is the digital scanner. So the first thing before we move on into an AI world is to have a digital scanner. Now, if we look at these digital scanners for digital pathology, which have come, many of them have come into the market, and the market is almost flooded with these digital pathology scanners. So you have got a range of these digital pathology scanners. They could be a single slide scanner like this, or they could be scanners in which you can put up almost 600 slides at one time. And there are multiple players which have come up for these digital scanners. So we'll be discussing more of the practical aspects of the artificial intelligence. So we have Motic, which produces 1, 6, and like 100 slides. We have Philips, which have got 200, 320 slides at a time. We have got Aperio, which is from Leica, which is also one of the very good digital slide scanner, which is available nowadays. And then definitely Ventana by Roche, which is also a huge number of slides can be scanned at the same time. Now, what this digital pathology slide makers are doing, they are integrating some softwares which, in addition to getting the slides scanned, that is whole slide imaging, these slide scans, they are going to do, so they are also building artificial intelligence algorithms which can help us drive at a conclusion just by scanning the slide. And why this is important, why this is so important, and this has come up in so much hype is there in the last 2 years. The reason is COVID. We have seen the world getting locked down because of COVID, and people could not come out of their houses. So what this COVID can do, has done actually, is we can have the ease as a pathologist to see the slides remotely from our home, and we can also do reporting. So that is the better part of this digital pathology, and that's why I say that we never know about the future, and this is definitely going to supplement the pathologist. So the first and the foremost question is, once you take a digital scanner, you scan your slides, maybe 1 or 2 or number of slides that you have, and it takes about 60 to 90 seconds to scan a single slide. So though it's a relatively time consuming process, if you are putting, like say, around 200 to 300 slides at a time, so the time taken by the digital slide scanners is relatively high, and at times they can have some problems in scanning of the slides. But the question is, if the slides are scanned, and if I'm viewing a whole slide scan imaging, can I sign out on digital pathology? So first question is, am I eligible to sign out on a case on digital pathology? So there have been multiple studies which have validated the digital pathology from time and on, starting from 2015 to the recent studies in 2023 and 2021, where most of these have come up from the bigger players like Philips and Leica and Roche. And they have done multi-center studies in US and UK, where they have validated, say, around 7,000, 5,000 slides, and they have collaborated it with the glass slide imaging. And finally, they have concluded that the correlation between the digital slide scanning and giving a histopathology report on a glass slide is very high. So The answer is yes. Yes, you can sign out on a whole slide scan image if you are getting one from a digital pathology labs. And this is the way forward, because if we are going to go into a world which will go again in the case of lockdown, then definitely you will have the ease of reporting at home and the work is not going to suffer. So the first question is, can I report from WSI? Yes, I can report. So now there are guidelines which are laid down by the College of American Pathologists, for which have validated the WSI images for reporting of histopathology. And what the guideline says, you should have a minimum of 60 cases in which you have seen these 60 cases on an H&E slide, and you have also seen them on the WSI images. And then if your correlation is over 90% for these cases, then you can go ahead and report on these WSI cases. The time period between the reporting of WSI and the reporting of glass sites should be a minimum of 2 weeks. So you should take a break of 2 weeks before you go for these reportings. And if your reporting correlation is over 95%, then you can definitely go ahead and do the reporting from a WSI. So that is about WSI, and that is one way to enter. That is not just one way, it is the only way by which you can enter into a world of artificial intelligence or the AI. Now, the importance of AI is, why we are so much looking into AI is because there is a huge cancer load in the country, throughout the world, that is globally. And every year there are 20 million people which are increasing for cancer load per year, and there are going to be a large number of people who are suffering from cancer by 2030. So 70% increase in the next 15 years in the developing countries itself. So it is not just about the developed countries, even our countries are going to see a very huge load of oncology cases in the coming years. For cancer diagnosis, an accurate diagnosis by pathologist is a must. So before he goes in for a therapy, you need to sign out a report in which you say that yes, this is a cancer, and you confirm it before the patient goes for any chemotherapy or surgery. In many of the low-income countries, you have less than one pathologist over a 5 lakh population. So even if you look at the developing countries, the number of pathologists who are doing the reporting is very less. And if you look at UK, there are only 3% of the current histopathology department that are adequately staffed. So basically, we see from these database itself that there is a huge shortage of pathologists. In the coming years, the disease is going to increase, but the number of pathologists is still very scarce. So this all we have discussed. And the major development that has come in AI is from the automated processing of image data. So previously, when we started doing artificial intelligence, we were giving manual feedback to the slides that we were looking. So the first project that we did with Microsoft, we were manually selecting the areas and giving them, annotating those areas and telling them that these are dysplastic, these are cancerous cells. But now that has moved from manual processing to an automated processing, in which there are networks in which you can feed huge number of image data. And that's how the Google lenses have come up, in which you just put an image and then you get many similar cases from the similar pattern. So the automated processing of image data, which is also referred to as machine vision or a computer vision. And this is a breakthrough in artificial intelligence, because after 2015, we have seen a huge surge of artificial intelligence algorithms and many softwares that are using these algorithms to come up with a final solution. So the major breakthrough that came was through the ImageNet dataset, which came up in 2010. So through this dataset, what they did is, it was by Lee et al. Who did this discovery. And what they found is you can put n number of images in the data, and through the CNN networks that we have seen previously, the data is going to analyze itself, and then it is going to tell you whether I am benign, I am malignant, or I am dysplastic. The only requirement for these image analysis is you need to put a huge number of data. So it is not just say 100 slides in which you are annotating it and telling it that these are dysplastic or carcinoma. You need to feed thousands and millions of images into these data sets, and then you can come down with an algorithm where you tell them that these are metaplastic or not. So this I will skip because this we had discussed. So machine learning, we were annotating the things, and now with deep learning, we are just feeding data into the machine, and that data is also huge amount of data. So it is not just say 5 or 10 slides, we are now feeding millions of images. And the best part of doing WSI is that you have n number of pixels of data which you can feed into the system. And once the data is fed into the system will come out with an output by itself, in which the system will train itself initially from the data that you have put, and then you are going to say some unknown slide is being put into the software, and then you are going to analyze whether it is telling you correctly or not. So this is the basic framework of the CNN model or the deep machine learning model, in which we are feeding large number of images. So through these deep learning models, what are the different softwares that are utilizing these deep learning models or which are feeding on the data of images? These are GoogleNet, AlexNet, VGG16 and FaceNet. And all of them have shown a very good accuracy between the images that are fed into the system and the results that are being obtained. So most of them have got an accuracy of over 90%. So what do we see when we feed these data into the DNN? And finally, what is the output? The output is we are going to get some sort of heat map. So if you have gone to an endoscopy, the Olympus have been utilizing these heat maps for long for the Doppler scan images. They are using this for highlighting the areas which are highly vascular and the areas which are less vascular. Now, explorating that areas, that particular thing in the tumor network is that we are examining these areas as red, in which it is actually a high activation index, and high activation index means these are dysplastic or these are malignant. And then the blue or the green, they are going to represent the low activation index, which means this is relatively towards the benign. So once you feed an image into an AI software, it is going to give you a heat map. And based on the heat maps, you can analyze whether this particular area is actually demanding your attention or it is not demanding your attention. If the areas are large enough, so like here we see that this is definitely a mucinous carcinoma. So you can just get away by seeing it on the microscope. But if you have got slides where you need to count the images, where you need to count the cells, and the cells are very scarce and you have difficulty in counting them, then definitely you can feed the data into the system, and you can get an algorithm which will come down and tell you that these are the atypical areas. So what are the benefits of AI or the current usage of AI? What are the applications where we are using AI currently in the market? The most commonly used application is for the breast biomarkers. And in the breast biomarkers, the current software that are exploring it is for ER, PR, and HER2/neu. So these are the three markers where they are giving you a calculative index. Once you feed the image of IHC into the system, it will give you that these number of percentage of cells are positive out of the rest of the cells which are negative. Similarly, we see a lot of subjectivity in the examination of the Ki67 index. So a Ki67 index reported by V would be very different from a Ki67 index reported by a second pathologist or a third pathologist. Why? Because there is a lot of subjectivity in the Ki67 index labeling. So utilizing this AI softwares will come down to a consensus and will tell you actually how many cells are lighting up with the Ki. So that is the beauty of getting a Ki67 done through an AI software. Then finally, we have got many AI index which are telling you now the diagnostic accuracy for prostate carcinomas, for gastric carcinomas, definitely for breast cancers. And a large number of softwares are using, especially from the Roche company. They are utilizing with the Ventana, they are giving a software application for PD-L1 analysis. So these are the current ones which are there in the market. And there are not many areas where the AI can be explored, but these algorithms are already being tested and they are approved by the European conformity. So they have got the licensing by the European conformity for usage in practice. But definitely apart from PD-L1, you are going to do an eyeballing through the slide before signing out a report of these AIs. So as the previous speakers have already said that you are not going to rely only on these algorithms. You will still look at the slide and finally you are going to report out the case. So we have seen cancer diagnosis in breast biopsies, in deep learning algorithms, in lymph node mets in women in breast cancers. Then we have histological diagnosis for gastric cancer that is given by IBEX. And then Roche has come up with a PD-L1 algorithm. Similarly, PathAI is doing a lot of work on the PD-L1 and carcinomas. So what is the utility? This is from the PathAI website itself. So what you do is you do take a, suppose this is a lymph node where by doing an eyeballing, you fail to identify any atypical cell in this particular case. And if you do an AI algorithm in this, you could highlight these heat mapping areas where these are all red areas that indicate there are some atypical cells over here. And then it is going to mark the areas on the slide which you are going to focus more carefully. So this is the utility of seeing an AI, that you can identify the areas which are hidden under the slide and you can pick up those areas. So similarly for this, you can identify that yes, there was a malignant cell there, and similarly a small area that is present in the center of the lesion. So now coming on to PDL1 IHCs, like I said, the most important application that has come for AI algorithms is for the Ki67 index and for the PDL1 algorithms. And most of the algorithms that have come in the market, they have got a conformity by the European market. That is, they are safe to use, but you need to do an eyeballing with this last slide to say that this is the final consensus. So what you do is through the PDL1, we all know that it is very difficult to identify or count the number of PDL1 in the given slide because they are very scattered, and some people would say that this is 10%, some would say this is 1%, and any number that is over 1% is critical. So if you have this particular area and you have to count the number of cells which are PDL1 positive, yes, it's definitely difficult. And if you have to do this in the entire tumor, then it is even more difficult. So what you do is you apply your software algorithm over here, and the software is going to read all the red areas, which are the tumor cells which are lighting up with PDL1. Then it is going to give a calculative index, and then it is going to tell you how many cells are showing up lighting by the PDL1, and you get an exact number that this is the number of cells which are PDL1 positive. You can always cross check it on your slide that if it is 10%, yes, it is being seen on the slide in the similar manner. So this is the beauty of these algorithms. But the problem with these algorithms is some of them are given free with this with the hardware that you purchase for the digital slide scanner, and some are available in the market which are very costly. So these, but in any case, they are going to eliminate the errors of subjectivity between the different pathologists. And then charting the path ahead. The charting the path ahead is you can do n number of research activities through these algorithms. So it is not just the identification of the tumor cells, that is the diagnostic algorithms that we are going to get through these AI labeling index or the softwares. We can also do the number of studies and research papers with the help of these index, in which we can identify what is the number of lymphocytes which are infiltrating the tumor cells. We can particularly identify what is the number of plasma cells in the tumor. We can also identify the number of macrophages in the tumor. So these are going to open a lot of avenues for research in the days to come. So that is the beauty of AI, and you can do a number of papers through these algorithms itself, which the software is going to give you. So you have the software, you have the stats in hand ready, and you can just publish a paper through these different algorithms, and you can tell the different prognosis of the patient based on the number of infiltrating lymphocytes or plasma cells. So likewise for the melanomas, if the number of plasma cells, infiltrating plasma cells are too many, then these patients have got better prognosis as opposed to those which have got a lesser number of plasma cells, and you can easily do the research based on these studies. So the problems, this we had discussed, there is a speed internet you require for reaching out to these algorithms. You need loads and loads of data to feed this into the AI algorithms to generate a very effective CNN network and finally a deep machine learning. But this is actually not a problem now, because most of the centers in US and many in India have now routinely digitalizing their slides and feeding the database into the system. So the data is already accumulating n number of cases through the through your softwares which are available. Then there is a problem in reporting of spatial stains. If you have got spatial stains, especially H. pylori, since the lesions are very small, so it is a difficulty in identifying those. Immunofluorescence studies are still not validated, and so is the polarizers. And most of the digital scanners that we use, they are utilizing a maximum of 40x, and most of them are not using 100x for identification. But this is less of a problem in histopathology because we get away for most of the cases by 40x imaging. So what's the future of AI? It explores the possibility of improving diagnosis and treatment. There are many chances of early diagnosis. It can give personalized medicine for use. So if I want my slide to undergo a software algorithm and tell me how many PDL1 cells are positive, I can get an exact number through that software, that these are the number of cells, and then I can get a personalized medicine based on that. Then we could get an ISC scoring, mitotic count, which is already there in the market, MSI testing, which again is there in the market, and HPV testing. So now the companies are exploring a single thing for AI, and then there are many more algorithms to come up as we see them in the future, in the near future. So the future of AI is we are going to see it pan globally, and we are going to see the cases not just from India. We would be able to see the cases from across the world. So we have now collaborated with HistoIndex for our for the Nash liver pathologies, and that's how it is going to explore further. So thank you so much for your patient hearing. I hope I was on time, and sorry for a bad throat. So I conclude my session here.
Thank you, Dr. Nalini. It was a very informative presentation, and we were able to understand how it is going to assist and help the clinicians and pathologists alike. Now we are at our back end of the webinar, wherein we have a lot of questions in Q&A session. So we will have some questions, and all the speakers are available to take those questions. So I invite all the speakers and Dr. Prashant sir to moderate this. There are few questions which we have picked up from Q&A. So the first question is by Dr. Pradyot to Dr. Rajan Verma. Which books will you recommend for beginners to learn AI use?
Hello.
Dr. Rajan Verma.
Can you hear me?
Yes, sir.
Yes, Dr. Rajan, yes, we can hear you.
So, see, the AI, you need to understand the Python language basically first, if you really want to start programming the AI. Otherwise, you have ready-made sets of DNN models which are available with a price. You can always purchase them and run your flight sets through them, and you'll get the desired output. But if you're so passionate, I would suggest there are multiple courses which are being offered for AI in healthcare. Also, there's a course by Stanford. There's a course by Coursera is there. So all these courses, see, the baby step to get into AI is to learn the basics, get into a professional course, and then start experiencing the AI yourself. Just reading a book won't help it. You need to understand the programming language, that is Python, at least, to do the networking bit.
Thank you, sir. Thank you. Thanks for the answer. Now, next question is to Dr. Pranab Dey. How did you confirm your cases as adenoma or CA on the models? Did you confirm on microscopy? The question has been asked by Dr. Shahabuddin. To Dr. Pranab Dey.
Thank you for this question. Actually, first, we took all the cases where histopathology was available after the cytology. So this is a supervised training where all the cases which we collected has the known histopathology. Now, if we look back to the cytology and train that model, which model itself it into 3 groups: training, validation, and
Dr. Pranab, we are not able to hear you properly. Audio is in trouble, I believe.
Pardon? So model, we have the histopathology group cases. Yes. Next question.
The next question to again Dr. Pranab Dey is, can we create our own data set from the slides and put it into reinforcement ANN so that we can change the diagnosis next time? The question has been asked by Dr. Kavita.
Yes. Yes, when you make your own model, you need your first data. That when you will eat the food, you have to cook it. To go to the market here, but the data set. No deep neural network, no convolutional neural network. So data we get images. It will be the particular area of the cell. So you collect the images data data about the nuclear area, diameter, perimeter, textural data, mitotic activity, cytological features data. I am saying on cytology, suppose. So all the data, even clinical information also, you can incorporate in this. Now you make your own model from that data set. Now, what Madam also said, I also personally worked on it about the deep learning, not company based. We made our own model. Just last case I have shown how we have made the deep learning neural network. We took all the cases, histopathology proof cases of benign and malignant diffusion cases, and lot of images we fed that the deep neural network we made ourselves from the Python, as he has made. You will have to. Now the problem is not so simple. Problem is very complex, because if you have a simple image, you have only few pixels in the image. Suppose 540 to 540 pixels. But if you have whole slide imaging, as Madam is said, whole slide imaging has a huge amount of data, unimaginable data. This data only you can process by repeated convolution. We use the filter. The filter we have put on the images, and it makes the images smaller and smaller and smaller and smaller. After 30 or 40 cycles, in a huge image will be a very small image. But Python, and we worked on the freely is available. Google Colab, you can go. Now you can take, as Dr. Rajiv Verma is saying, ChatGPT. He may guide you, but it may be a wrong guide many times. You have to see what is your problem? How will you make your model? That you have to make your model yourself. You cannot based on the computer, company. Company will give you only 4 or 5 things, and they will ultimately suck you. Suck you means they give you the initial license, then after 1 year they say stop license, and then everything will fall down. So you have to make your model. So we have made our own model. There is no book here. You have to take the course coaching from the Stanford University regularly gives that, as he has said, and you have to know the Python. There is no shortcut way of the success. You have to learn these 2 things. One is that how to use the WSI. That is very easy. How to make your model. What is your problem? So you can do successfully on deep neural network on your own data.
Thank you, sir. Thanks, Dr. Pranab Dey, for your elaborated answer. Now, the next question is to Dr. Sonal Jain. The question has been asked by anonymous guest. Is there any AI application suggesting battery of blood tests for any differential diagnosis, at least to rule out and guide the primary level cancers?
So I would say that you can use ChatGPT for that, but as Dr. Rajan has pointed out, that it has hallucinations. So I'll give you, and you can do that, but that is not something that's advisable. Because I give you an example, as making a presentation, just for the ease of it, I'd put in that software, tell me sickling test, because it was never taught what a sickling test. What it told me that you make a smear and you heat it, and the cells get sickled. So I mean, it's best to be left to the wisdom. Differential diagnosis is not something which should be doing using, I mean, based on clinical data. Yes, there are softwares, but it's best to be left to the clinicians or the pathologist experience. This ChatGPT is even, I mean, try it out. It does give you differentials, but making a test list based on that would, I guess, won't be advisable.
Thank you, Dr. Sonal. So that was the questions at my end. Over to Dr. Prashant. Prashant, sir.
Yeah, actually, everybody has appreciated our webinar, and they are very happy to see all of our speakers, and many of our delegates knew everybody. So they have congratulated you all the speakers for having such a grand show. And few of the questions which I would like to take is one is by Surinder Kataria. We pathologists can accept any challenge, and AI is a long way to go in improving our diagnosis. Can you give details of the company providing software with AI in different subjects like hematology, bone marrow, and FNAC? So over to you, Dr. Verma or Dr. Sonal.
So Sonal, over to you. That's a subject matter question.
So, as I had mentioned, the digital slide scanners, those same companies also have their own softwares for analysis. So, couple has shown it. AI100, Vision has, Samamatsu has, Hemocyte has its software which analyzes the cells. So, there are a good number of them. Sysmex has its own software, DI60, which is Mindray has its own software. So there are, and as I sir said, you have your own data and you make your own, that's possibly the best.
Okay. Another question by Dr. Matthew that to Dr. Nalini. How sure can we be sure of Ki67% if the tumor cells are mixed with non-neoplastic cells like lymphocytes, etc.? Ma'am, your voice is not coming. Please unmute yourself.
Yeah, it's okay. So as I always said, that that will be there because Ki67 would definitely be mixing up with the lymphocyte. So you need to see the slides also to avoid any false positive result. But the current AI algorithms that have come up, especially for this IBEX system and all, they are very good. So they give a very accurate data, and we have analyzed cases from the Ki67 itself from the IBEX system that is available. And then the amount of staining of the Ki67 of the tumor cell is different from those of the lymphocyte, because lymphocyte size is different in the CNN network. So if you are in doubt, you can but they are different for the different softwares. So many of them like QPath is giving a free image analysis software, which is available. You can just put a WSI into the system and then you get an algorithm out of it. So there are certains which are available free of cost, and then there are certains which are there, which are there for the commercial purposes. But if there are certain softwares which have actually looked into this problem of looking a difference between the lymphocytes and the tumor cell, and then they give a very accurate result. So there have been studies which have validated Ki67, and Ki67 was initial markers to be started in the ISC algorithm. So it was one of the first markers to be started getting reported from the AI algorithm. So that's how it is useful. And if you are in doubt, if you're using some other software, if you're using some free softwares, as I said, you can always go back and look at the slide and then just correlate whether these are okay or not. So as I said, AI is going to supplement us. It is not going to replace us. So this, if we think, it is an ignorance. Just like when the platelet count came by Sysmex, people used to think that hamara to kaam khatam ho gaya, pathologists are zero now. It is not like that. It is only that, as I've told you, that the number of disease load is going to increase in the coming years, and it is to the tune of say around 70%. So the number of pathologists would be required for diagnosing those cases, and AI is going to supplement us for that.
So there is a software online which is called i4ia. So users can go to this website called i4ia and upload their images for Ki67 indexing as a demo. It works very well. It's a free tool to be used, limited time, but it works very well. But the whole story is that it needs whatever data and whatever outputs you're getting, it needs to be validated. A very strong validation is required. When you change an antibody, when you change a staining pattern, whatever you do, you need to do a validation, run it again through the data sets, because you will start getting haywire results if you don't do validation when you change anything which is a rate limiting step there, or a quality oriented step. So very important.
One more question is by Dr. Sangeeta Singh. How will the expenses increase if used in future? Will the manual method be gold standard for confirmation of any abnormal finding or report? or we can go with the AI?
AI is always
Definitely,
supportive.
yes.
Yeah. AI is always supportive. I feel that, and it will take ages for AI to evolve to become superior than us. I can't say what DNN would lead to because the self-learning is very strong at the moment. And there are some, I forgot to tell you, there are some filters being placed purposely inside the chatbots because they don't want these chatbots to go off track. So these are called filters. They are put in purpose, and there is a strong regulation that these filters need to be put so that they don't become a supreme power or a computation power more than the human brain.
So I'll just add to it that we thrive on, so biological variation is immense. As all of us have highlighted that AI learns by the data set it is fed with. And that data set cannot match the heterogeneity of human biology at any point, whatsoever level of learning it may have. So in our practical experience, howsoever experience we may have, but someday we get stuck up in something that this is new or this is something I've not seen before. So we can't expect AI to have all the answers. And if we are doing so, I would again reiterate what I said in my presentation. We were created by that supreme power and we are perfect. We are the best creation on the planet. If we say that what we created is better and it can, I would really...
Very well said,
Hey,
Dr.
this is,
yeah.
Actually, I have certain things to say. You think that you are the supreme power. Yes, it's okay. But there are many things you cannot take the decision. There are many things in life also. And now do not underestimate the power of AI. Because not only WSI or whole slide image scanning is coming, the very complex genomic data from NGS is coming. I have not discussed this in detail. You introduce this data with your image data. You introduce the clinical data. You introduce the biomarker data. No human being can immediately interpret this data. Now, when you make the algorithm yourself and give all the data, you will see the miraculous result. And I am very hopeful. Maybe I am wrong, but in future, if we are alive, within 20 years, you will see there is a massive development in pathology. Definitely. It may replace your routine reporting. When we were in hematology, it was done by us, the blood differential count and these things. And it took a lot of time. We were habituated. Then when the flow cytometry machine came, so we say absurd, it is a nonsense. It cannot do that. But nowadays, you see, everything is done by that things. Auto-analyzer, everything is done by the auto-analyzer. And the day I am saying is coming when it may replace your routine report. Wherever heterogeneity is there, it will accept when you have a huge amount of data from different parts of the globes. And the data company is giving, you are giving, many in continuously data is collecting. And when you use the data, miracle will happen. You just see this. The coming years, you cannot neglect that. Okay, we are the supreme things. Yes, you are supreme things. But there also you get so much help. You will say, let's the car drive. And the car will take you from New York to Texas. And it is happening. Actually, AI is more dangerous than the atom bomb. It is the immense power it will open. If you cannot control it, it may destroy the civilization.
There is only one thing which is restricting the AI in becoming supreme is the emotion. So the AI has everything what we have except the emotions, and now we are suspecting that some of the AI has shown emotions also, as it happened in the news also, and it's terrifying if that comes up.
So I would opine that everything that is repetitive can possibly be taken over by AI. So we have to keep evolving ourselves. We have to use what it is learning and learn learn newer
have
things
to
at a faster pace.
Yeah.
You can't be in our comfort zones and think that
You
I
see,
know.
Dr. Sonal, the problem is our DNA ages and has limitations. AI never ages and AI that doesn't have limitations. The DNA keeps learning, keep making nodes by itself, keep modifying the algorithms. The algebra equations are modified automatically by the AI to suit its own needs. And that's how it is evolving. We will age, we will become senile, we will have Alzheimer's. DNA will never have. That is the biggest challenge.
DNN will get a bug. DNN will get a bug, and then the software will be released.
No, these bugs
No.
are put in on purpose. These bugs are put in on purpose. They are the industry standards now.
Yes.
In fact, I have to say another thing. You must be knowing that Google has already was successful to make a quantum computer, and if the quantum computer comes, you will not have the imagination how much power is it. And this quantum neural network, if you see the Nature journal, it has come, different articles are coming, and then the immense amount of unimaginable data it can process within millionth of a second, and it will give you miraculous result. This is beyond our discussion. In fact, quantum neural network is coming. You just open in PubMed, and quantum computer Google was partially successful because it takes huge amount of space and money, but it is coming. And if you will replace the normal computer, normal neural network, normal deep learning network will be replaced by quantum neural network, then within 10 years you will see the miracle is happening.
Sir, one more question has been asked by Dr. Karan Mourya, that Python and which course from Stanford? You mentioned about Stanford. He was asking which course and how we should learn.
See, all the answers, Dr. Prashant, I would suggest the beauty of ChatGPT is put all these questions in ChatGPT and it takes you to the course of Stanford.
Okay.
And you try it. I can try it really in front of you in live. It'll tell you 6 more courses across the world.
Yeah.
Not only Stanford. Let me tell you that. And it'll take you to the website.
Yeah.
And the chatbot there at Stanford will get you admitted.
We had a nice discussion, and I think the next CME will be planned soon, and we should interact on our WhatsApp group so that we will make it more lively and can interact with each other more. And I would request everybody to please share any other speaker or any other good speaker who can contribute in our next webinar. So please feel free to communicate with us. And over to Varun, please give your presentation.
So, by the way, one last information that ChatGPT for WhatsApp has come in. It's called Viz AI.
Oh.
So you can all load it on WhatsApp, and you will not have to open up the app. You just ask the question on WhatsApp. It's going to give the same answers as it does on the net. It's called Viz AI. And please go onto the internet and you just click that link and it comes on your WhatsApp. Nothing else will be done.
Very nice.
So thanks, Dr. Prashant. In the interest of time, I have just 1 or 2 slides to share that what Mindray have been able to achieve in terms of introducing artificial intelligence to our hematology arena. So just a moment, I'll share my screen. Is my screen visible, sir?
Yes.
Yeah.
So MC80 is our automated morphology analyzer, which we have introduced last year. That is a morphology analyzer which accepts slides from SlideMaker and SlideStanner So far, it has not been able to accept the slides which are manually made, but the slides which are made by a modular system, slide maker and slide scanner, it can accept those slides. And what it has been able to do is to improve the last mile in hematology test automation, because as of now, the slide making, slide staining, as well as morphology analysis was not automated. And it resolves the risk of missed test. And also it makes accessible the automation to save manpower and improve the efficiency. How it does, because this is the schematic diagram, how the instrument works. So basically, it is a part of hematology automation cell line, wherein the sample is being analyzed on the automated analyzer. Then it goes to slide maker, slide scanner based on your rule setting. So whatever rules you have set up, that let's say if there is a WBC more than 20,000 or platelet less than 50,000, you want slide to be made. Those samples would travel to the slide maker and slide scanner. And then those samples, the slides would travel to morphology analyzer, wherein the morphology analyzer has its own neural network and AI in place, and it will do the pre-classification. And all the cells, if at all there are any cells which are not being able to be classified, they would be termed as unclassified, and you will have the liberty to classify them based on your understanding. How it works, it looks at various characteristics of the cell, like color characteristics of nucleus color, granule color, cytoplasm color, and the texture of granules or fineness of chromatin, existence of the nucleoli, and then geometric characteristics of NC ratio, cell size, and shape. And it based on that information, it does the pre-classification. The same thing is done for RBC as well, where it looks at the color characteristics and geometric characteristics. And the best part about MC80 is that unlike other competitors, wherein the other instruments are doing very good job for WBC and RBC, but for platelet, there is very little to offer. However, MC80 has a mode called Platelet Pro, wherein it can go into the edges, look at the platelet clumps, and give you the estimated count from the platelet clumps as well. So you will not miss even the clumps, and the platelets confined into those clumps would also be reported to you. So it has the ability to go into the edges, look for the clumps as well as the blast cells as well. They can be picked up. So by introducing this, the instrument is able to introduce more clarity, more intelligence, and more productivity into our hematology analysis. And this is how the instrument works. It prepares 3D images by looking at 20 different depth levels in the slide, and then it prepares one complete image, which is then analyzed by the intelligence available. And then it is able to introduce smart smear reading rules, well-established re-exam and auto-validation rules, which are already pre-decided by you. And then based on that, your hematology test workflow is very well standardized. So I'll not take much time. Just wanted to tell that Mindray is the only manufacturer of hematology analyzers, which has its own morphology analyzer as well. So by doing that, we have been able to integrate hematology CBC data as well as the morphology information on the same screen, which makes decision making pretty easy. Also, the digital morphology software as well as CBC software is accessible from remote location. So let's say the instrument is in the laboratory and a clinician wants to access the information for sake of any understanding, or even a pathologist sitting at their own home or ease of place wants to access all the information, they will be able to access all the information, including the numerical data, the graph interpretation data, and the morphology data from ease of their own comfort. That's what we have been able to introduce. And I'll not go into the details in the sake of time. So thanks everyone. And with this, I end my presentation. Thank you.
Varun, everybody wants to know the price of this instrument.
Sadly, that is one thing which have been already discussed by all the speakers, that price is something which is still on the side, which is not so affordable. But let me make sure that with work volume, if work volume is sufficient enough, price will not be a barrier. And at the same time, all the manufacturers, including Mindray, are working really hard to make sure that it becomes accessible in very near future. So we are working the best what we can do to make it more accessible.
Yeah, thank you.
So that's our assurance to the fraternity on the other side.
Yeah, thanks. With this, we would like to end this program, and as a representation of Association of Practicing Pathologists, I express my heartfelt gratitude to your participation in this remarkable webinar. This is our first introductory webinar. We shall be having more webinars soon. We need contribution and cooperation from all of you. Whoever is interested, please send your details to me. We want our WhatsApp group to be more interactive and participating. Please put your queries and studies on this subject to enhance the experience of everyone. I would like to thank all the delegates who have joined today from various parts of India. Thank you for investing your valuable time and being the integral part of this event. Your presence and active engagement have made this webinar truly special and impactful. A special word of appreciation goes to our esteemed speakers. Your knowledge, insight, and expertise have enriched our understanding of how the AI is transforming the field of pathology. Your contribution have been invaluable, and we are honored to have your share of your wisdom with us. I would also like to extend my sincere thanks to the Mindray for their meticulous planning and execution. Your efforts behind the scene have made this event a seamless and successful experience for all of us. As we conclude this webinar, let us carry forward the learnings and inspirations we have gained today. Let us embrace the possibility of AI in pathology and use this knowledge to drive enhance advancements in our profession. Thank you, everyone. Thanks a lot.
Thank you, everyone. Thank you. With this, we end. Thank you.